Okay, let's go back to the formula sheet. I wanted to show you on the formula sheet, we do have some basic pieces of information here regarding derivatives at the top. We've got the product rule, quotient rule, and chain rule listed in the middle. And one thing at the bottom here I want to point out is that for this problem, the problem number 3 on the in-class problem set, it's got to do with these gravity-related formulas. And this formula here, I'm going to put on my iPad, and we'll work with this, and then we'll work with the problem that's given in the problem set above here. Okay? So I'm going to put this up on the formula sheet right now on my iPad. We've got S of t. Like I was saying, on the formula sheet, it shows the standard form when you're talking about the English system. S of t equals negative 16t squared plus v sub 0 t plus s sub 0. We'll develop this again as we get a little closer to doing antiderivatives and integrating. But I wanted to show you the formula that we're working with in this problem is this. We've updated it to make things correct here. We got S of t equals negative 16t squared. We're talking about the initial velocity, v sub 0 in our case, starting at 64 feet per second. And the initial height of the building, the top of the building, is actually at 80 feet, is the correct way to be looking at this. All right, and what I want to do now is go through that problem on the iPad and make sure that we're working through this. It's a fair game question I'll be asking on the test tomorrow. So what I want to point out is, what we've got here in the diagram is we're starting here and a rock or an item is propelled down and it goes over and hits the ground here. And this is, we're at our start point. We're saying that this is at 80 feet, 80 feet, okay? And this is our time 0, all right? And we're at 80 feet, and the initial, it's propelling up at 64 feet per second. So the first question is, on the sheet, how high does it get at 1 second? It's being propelled up, how high is it? This formula is the height, the distance the item is from the ground at time t. At 1 second is what the question's asking. The first question, how high is it at 1 second? Well, let's plug in a 1 to figure it out what it is. So S of 1, t equal to 1, is equal to negative 16. Yes, I'll go ahead, even though we know the t's are 1, and the answer is pretty straightforward there. But we're going to recognize that this is negative 16. This is meant to be a 1, right? Plus 64, plus 80, and that equals, what do we get? Minus 48. That's positive 48. That turns out to be 128. So A, the answer to part A, how high is it after 1 second? We get 128, and a part of a correct solution there is feet. 128 by itself is not a completely correct answer. You need the increments as well. Okay, and then let's go back to look at the second part of the question, which had to do with writing the velocity formula at any time t. So what we do, being that the rate of change of the position is the velocity, rate of change is talking derivative. So what we've got for part B, where we're asked for the velocity function, is we take the derivative of S of t. That is going to actually be the velocity function. And if you look at the position function, we got negative 16t squared, bring the 2 down front, multiply it by the negative 16, you've got negative 32, subtract 1 from the 2, and you've got t to the 1. And then the derivative of 64t is 64. The derivative of 80 is 0. So we end up with the velocity function. The answer to the second question, part B, is v of t, the velocity function, is asked for the entire function, which means 2 sides of an equation, is equal to negative 32t plus 64. All right. Then part C, how high does the item actually get? The situation has to do with when we're talking about going up, the velocity is a positive velocity in the physics perspective. Coming down, it's negative. So that means between positive and negative, there must be a zero somewhere. So where is the velocity zero? Going up, it's positive here. Going down, it's negative. When is it zero? Well, when is velocity equal to zero? Set the derivative equal to zero, and we will have found the t when we've reached the top of that graph. So if we set negative 32t plus 64 equal to zero, we end up with 64 equals 32t, t equals 2. And again, it's not just 2. The answer to the question is when, what is the time? It is 2 seconds. Okay. The third question is, how high does it get? And the circumstance there is, D is, how high does it get? Well, how high is it at 2 seconds? Well, what is S at 2 seconds? It's S of 2. S of 2 equals negative 16, 2 squared, plus 64 times 2, plus 80, ends up being 4 times negative 16 is negative 64, plus 128 plus 80. That is equal to what? 64 plus 80 turns out to be let's write it out. We got 64 plus 80. That turns out to be 144. Therefore, the max height is 144 feet. Okay? So notice this. It happened at 2 seconds. This is happening at 2 seconds. At 1 second, we were at 128 on the way up. It's not exactly halfway. It's slowing down as it's going up here. So after 1 second, we are at a particular value. At 2 seconds, we're at the max height, and that turns out to be 144 feet. Okay, this is 80 feet here. We're at 144 feet. Notice it's symmetrical. Therefore, after 2 more seconds, that's at 4 seconds. This is 2 seconds. This is at 4 seconds. We're going to be back to 80 feet. And if you plugged in 4 into the function, you would see you end up getting 80 again. All right. Well, here's what I would like to point out is that that is 144 feet. Now, the last question is, when does it hit the ground? And that is when S of t, the distance above the ground, is equal to 0. So that means S of t equals 0. So we've got the original function equal to 0 will tell us the value of t when it is actually 0, when the function is equal to 0. That is when it hits the ground. So we set it equal to 0. It allows you to factor it, which is negative 16. I picked numbers, not a real life situation, but we end up with, if I take minus 16 out, I end up got to change the sign. That's minus 4t, and that turns out to be minus 5. And if you notice now, if I divide each side by negative 16 now, it's going to cancel out. 0 divided by negative 16 is still 0. So the only point that's going to affect this circumstance right now is the factoring. So we've got t, and to determine what time it will cause the function equal to 0. That negative 16 won't do it. But we end up with 5 and 1, and the minus is negative 4, so it's got to be minus 5 and plus 1. Therefore, we've got t minus 5 equals 0 and t plus 1 equals 0. That gives us t equals 5 and t equals minus 1. We know that minus 1 doesn't make sense time-wise in our circumstances, so t equals 5 is 5 seconds is the answer. Now notice on our diagram, 4 seconds brought us back here. It says 5 seconds hits us here. 4 is there. 2 is at the peak. Yeah? And notice where the negative 1 is. At negative 1, we get 0. So if this a parabola was continued, you notice it would go back down, and at -1, it would match and make the function equal to 0. Time-wise, that doesn't make total sense. Okay, so what I want to do is to mention that these are the 5 answers for the solution. Notice the increments are there in each situation. Show your work. This is a fair game question I'll be asking again tomorrow on the test. So those basics, make sure you're familiar with it, and let me know if you've got any questions, okay? Right now, we're going to switch and go over to the Zoom room, the office hours, Zoom office hours, and let me know if you've got questions there, okay? So I'm going to drop off now, and I wish you well on the test. Make sure you get in touch with me if you've got any questions.